We have gone through perpendicular bisectors, angle bisectors, and we're going to do two more that are similar to this today. So what you need to know is that the perpendicular bisectors meet at a point called the circumcenter, and that point is equidistant from all three vertices. So, at the end of this chapter, when you take a test, you are going to have to sketch some of these things. So when you sketch them in, you just estimate where the middle is, because you got to go through a bisector, and then you make it close to a 90, as close as you can.
Okay.
It won't always hit this other point here. Sometimes people think it's got to. And then you got to put in a 90 and show that it's bisected. Then you do the same to the other side. Put it in at about a 90. The only way it will go through all the points is if this is an equilateral triangle. And then show that that's bisected. And then the third one is going to go through there too. Show it's 90 and show that it's bisected. So, in an acute triangle, that point will be inside it. On a right triangle, it's on it. There's one perpendicular bisector, there's the other, and they meet right on the midpoint of the hypotenuse.
With the perpendicular bisector of the bottom leg, would that be parallel to the leg?
Yeah, it would be parallel to that.
And
And this would be parallel to that side. The reason why is because same side interior are supplementary, or corresponding or equal. Okay, so then this one, if it's an obtuse triangle, it's going to meet outside, right there. On an angle bisector, those meet at a point called the incenter. It's equidistant from the sides. So when you draw an angle bisector, you just got to cut it in half as best you can and then show that that equals that. Do the same to the other ones, show that that equals that. And they will all meet there. I'm off a little bit on my sketch, but it's okay. So, that's the incenter, because you could draw a circle inside it then. So this distance, and that distance are the same. In here, it would be this piece, and that piece. There, and there are equal. And here it's there, and there are equal. When it's an angle bisector, they will always intersect inside. And the reason why is you got to put a circle inside, so they obviously would. If you bisect that, and bisect that, it meets right there. Here, right there. Okay? So you do need to know the names of these on a perpendicular bisector and what they do. So you need to know perpendicular bisectors meet at a circumcenter, and that point is equidistant from all three vertices. You need to know angle bisectors meet at an incenter, and that's equidistant from all three sides. So now there's two more things we got to add today. Medians and altitudes. A median connects the midpoint of a side to the opposite vertex. So these are maybe the easiest to draw. If we've got, I'm going to make these a little bit bigger, an acute triangle or a right triangle or an obtuse triangle. So like here, it can be in it, on it, or outside of it. For angle bisectors, it's always inside. these are also gonna meet. Any idea where it'll be?
No.
Always inside. So when you draw these, you just gotta estimate where the midpoint is, and then you gotta show that it's the midpoint, and then you just connect it to the opposite vertex.
That's it?
Yep. So then you estimate where this middle is, and then you just connect it to the opposite vertex. That's a
You
little
just
crooked.
guess?
Yeah. And then the third one will always, they'll always intersect also.
You just
So we
estimate?
don't have to measure these, we just guess.
Well, when we're sketching them, you just gotta guess. If we were doing this as a construction, we would have to find the midpoint by
So the-
doing the perpendicular
So the median
bisector.
is where they all meet.
Yep. So, these will always meet at a point. It's a point of concurrency, just like concurrent means they're all on the same line. And that has a name called the centroid. So here, if I did that midpoint to there, midpoint to there, and then this one would go right to there. There's the centroid. And here. Okay, now the centroid, this point is used to draw a circle around it, that's why it's called the circumcenter. This point is called the incenter because you could draw a circle inside. A centroid is actually the balancing point. If you cut this triangle out and balance it on your finger or a pin or whatever, that would be where you'd have to put it so it would stay balanced. Understand what I'm saying?
Yeah.
Okay. Now this also has an application, like here, this is equidistant from the sides, this is equidistant from the vertices. The easiest thing is for me just to show you. Anytime you draw in these medians, it cuts each piece into two segments. So this whole median here is this piece and this piece. This one's this one and this one, this one's this one and this one. Just if you had to guess, if this length was 4, or 8 I mean, and you had to guess how long this was, what would you guess? 4. I accidentally said the answer. If this piece was 6 right here on this median, and you had to guess? 3, that's all it is. The smaller piece is always half as long as the bigger piece. So if this was 5 right here, this would be 2.5. Now what they say on this, it's easier to remember it that way. The longer piece is double this. If this was labeled A, B, C, point A, point B, point C. AB is 2/3 of AC. All that means is the longer piece is 2/3 of the whole thing. And the shorter piece, BC, is what fraction of the whole thing? 1/3 of the whole thing. Because if you did this as a fraction, which there's 2 problems like this on your assignment today, the ratio of AB to AC is 8 to 12, which reduces to 2/3. Divide that by 4 and that by 4. The ratio of BC to AC, and again in your assignment today, they're going to tell you to find this ratio. So all you do is you look at the picture and put the numbers in. BC here is 4, and AC, the whole thing, is 12, which reduces to 1/3. It'll always reduce to 2/3 and 1/3. Then the altitudes. An altitude, you guys know what the word altitude is, like in an airplane?
How high?
How high it is. So altitude is just the height of a triangle. So what it does is it's perpendicular from each side to the opposite vertex. Now these are a little harder to draw. The acute one isn't. If we had an acute triangle like this, all it is you're saying how tall this is. So if you had to measure how tall it was, you just measure straight up and down, right? So all it is it goes from one vertex to the opposite side, and it's perpendicular. It doesn't go to the middle like the medians. It could. If this were equilateral, it would. And then if you could picture turning this thing, and this were the bottom, then you'd want to measure how tall it was to here. So you would measure there, if this were the bottom. And then if this were the bottom, you'd want to measure how tall it was. Again, these will all intersect at one point.
Does it matter what direction you put the perpendicular side in?
No. And that point is called the orthocenter. Now, I've never seen, and I've looked it up, I've never found anything, if this has any application like these do. Centroid tells us this stuff. In-center tells us equidistant. Circumcenter is equidistant.
Maybe they
Orthocenter doesn't tell us anything, it's just a name. And of all these three things on the MCA test that you guys take next year, this is the one that they had on there for some reason, I don't know why. No idea why this is important, but they have it on there, so. So, it just tells you how tall it is. So you just gotta go from the vertex to the other side, making a perpendicular. So on a right triangle, make sure this is still on there. On a right triangle, if this were your bottom, this is actually an altitude, because it tells you how tall it is, perpendicular to the opposite vertex. If you turned it and this were the bottom, this would tell you how tall it is, right? From the opposite side of the vertex. If this were the bottom, it would be like this. Tells you how tall it is. So there it meets right on the corner. That's where it's similar to this one. So it meets inside, on, and where do you suppose the other one meets? Outside. This is the harder one to draw. If it's obtuse, one of them is easy to draw. It's this one. If this were the bottom, this would be how tall it is. If you could turn it so you measured how tall it was. Here's where it might get a little confusing. If you think of this like a building, and the roof juts out over, and you wanted to figure out how tall that roof was, where would you have to stand to measure it?
Outside.
Right here, right?
Yeah.
So what you gotta do is you gotta extend this side out and then put a line to show that that's how tall it is. That make sense? Because it's gotta go from the vertex to the opposite side and form a 90. Well, there's no way I can draw a line over to this side, so that's why you extend it. Same thing from here to there, I would have to extend this out. If this were the bottom, I would measure up like this to figure out how tall it is. And I should use red. They would intersect if you extended these down. But I'm off a little bit, but they would intersect down here. All three of those. So that's what we're doing today is the medians and the altitudes. Yeah.
Is it a worksheet or is it?
No, it's in the book.
Stop talking.
Okay, so this is where it tells us that R is the centroid. So this is why you need to know what a centroid is. Centroid is the medians, which means in this picture, this equals that, this equals that, this equals that, and this piece would be double that piece. This piece would be double that piece. And this piece would be double that piece. So that's why you need to know what a centroid is. So in this picture, they tell us SR is 16. So what would RV be then? Someone said it? 8. The short part is always half of the long part. And then what would SV be, the whole thing? 24. That's what half of your assignment is like that today. Finding coordinates. We got like 4 problems where they give you a graph like this, and you got to answer 4 questions on it. Find the coordinates of the centroid C of triangle DEF. So a centroid, remember, connects the midpoint to the opposite vertex, so there's one right there. Here we got to go to the opposite midpoint, which they put it on here as G. So you only need to draw 2, right? Because the third one's going to go through. So there's the centroid. So that coordinate is 5 over 3 up. All right. If they asked you to find the distance, which they do in your assignment, of E, they'll have a point there. All you gotta do is count. If it's straight up and down or side to side, you don't need to use the distance formula. The only time you need to do that is if it's an angled line. So this distance is 1, 2, 3, 4. This distance is 2.
So what's be 6?
The whole thing then would be 6, yeah. Okay, so again, this is the centroid. TU is 7. So how long is QU? 14. And then the whole thing, or QT is 14, sorry. The whole thing, QU, you'd add them together, would be 21. We're gonna do a couple together if you wanna get your book out. It's page 282.
Do you need graph paper?
No.
Is that your paper?
What's the assignment?
Okay, on page 282, it's 3 through 12. Seventeen through 20. So these first ones, here they give us a picture and they give us a piece of information. We gotta say from that information is e.g. the blue line, a perpendicular bisector, an angle bisector, a median, or an altitude. So they tell us that DG is congruent to FG.
So I mean, it's
Perpendicular
actually right.
bisector.
Okay, no, there's no 90. So I mean, it's a 90 then. It's the same, it splits it in half.
It splits it in half, so what is it?
Median.
It's a median.
It's obvious. Karen, use your brain a little bit and think.
Cause there's no 90, so then it wouldn't.
Right, so there's no 90, because we can't, so then we can't say perpendicular bisector.
The next one says 90, so.
So then here, EG is perpendicular to DF.
Perpendicular bisector.
Do we know it's bisected? No.
Free.
Angle, no, median.
Altitude. And altitude goes from the vertex to the other side, and it's perpendicular to the other side. Five, angle DEG is congruent to angle FEG.
Perpendicular bisector.
Is there any perpendicular or bisected in there, sides?
Angle bisector.
It's an angle bisector. It cuts this angle into two. You can just put the angle sign if you want. Angle bisector. Pretty soon it'll be perpendicular
This one
bisector,
is
don't worry.
No, this one's not.
Here, EG is perpendicular to DF, and DG is congruent to FG.
That's a perpendicular.
That's a perpendicular bisector. It's also, it can be more than one thing,
But it's not.
but it is. What else is true of these four things?
Altitude.
It's an altitude because it forms a 90 and goes straight up.
Do we just have one of them?
No,
We have to have all of them.
you can abbreviate altitude, ALT.
Oh.
And what else could it be?
You can do angle bisector.
Well, do we know if the angles are
Median.
bisected?
Yeah.
Median.
It could be a median because it goes from the midpoint to the opposite side. We don't know angle bisector because we don't know what the angles are up there. Then the last one, triangle DGE is congruent to triangle FGE. So what that tells us is all corresponding parts are equal. This equals that, this side equals that side, shared side, this angle equals that. And these two angles are equal, which means they'd have to be
Perpendicular.
90.
So that one would be perpendicular bisector
So-
or
Perpendicular bisector, the
angle
angles are
bisector.
equal, so it's angle bisector. It goes to the opposite mid or vertex at a 90, so that means it's an altitude. And it goes from the midpoint to the opposite, so that means it's a median. So in here now, remember, this has to do with the centroids. They give you what some lengths are, and they also tell us DE equals FE. So that means this side equals this side. So then you just gotta find the lengths and all that stuff.
Wait, for DH, since DH is 9, FH